If a matrix is not square, we can sometimes have forms of inverses. So if A is an M by N matrix, sometimes it will have a left inverse, C, such that C times A is equal to the identity, the N by N identity. This C would be an N by M matrix. All right, this is a left inverse because it multiplies on the left to give me the identity. This can only be the case if matrix A has a trivial null space. That's because, let's suppose that CA acting on vector x was equal to 0. Well, if CA is equal to the identity, then that means identity acting on x is equal to 0, which means x is equal to 0. So we'll have a left inverse in exactly the situation where the null space of A is trivial. That implies that the columns of A are linearly independent. So it would have to have a pivot in each column. All right? What about a right inverse? So now we're multiplying the matrix on the right. And we would say AD is equal to IM, the M by M identity. All right, so let's see how this, or what we require in order for this to be the case. So if AD is the identity, all right, then that means AD acting on B is equal to B for any vector B in Rm. Now I could view D acting on B here, and it would be a solution to AX equals B. So what I'm getting at here is that if matrix A has a right inverse, then that means that it's not possible for the system AX equals B to have no solutions at all for any vector B in Rm. Okay? Since it's not possible for that system to be inconsistent, A must have a pivot in each row. Okay? So if I've got a non-square matrix, it will have a left inverse if it has a pivot in each column, and a right inverse if it has a pivot in each row. That implies that the only time a matrix can have both a left and a right inverse is if it's a square matrix, and it would then be invertible. So let's see what would happen if A is squared as a pivot in every row. Well, that implies it has a right inverse, but since it's squared, that also implies it has a pivot in every column, and that would mean it has a left inverse. So let's see what the relationship between those inverses is. So I would say AD is equal to the identity. And now I could multiply by this left inverse on the left. Since this is the left inverse, CA must be the identity. So in this case, if A is square, its left and right inverses are the same matrix. And we just call them A inverse. All right, and this is why we say that such a matrix is invertible.